Hello, my name is Samantha Tierney and I am one of your classmates. Today I'm going to be discussing temperature and the metric system. So, a real world application. About a year and a half ago, I went to Australia to visit one of my close friends, and I realized while I was there that they were doing everything in Celsius, in kilometers, and meters. Unlike here in America, where we were doing Fahrenheit and miles. And so the whole time I was there, I was having to do conversions just to figure out how hot it was, because it was the middle of summer there while it was winter here, and it was extremely hot. So, metric system. The metric system is actually just factors of 10. I know currently we all use centimeters or millimeters in our standard English here in America, but it's also a standard measurement in most other places in the world. So there's actually base units, which you'd have liters, meters, grams, and seconds, and they're always have a prefix before them. And so here are your prefixes. So think about it. Centimeter, centi, and meter. And that's how we come up with the factor of 10 and the name and the label and the conversion. So here's a list I've created for you. Tetra is 10 to the 12th. Giga, 10 to the 9th. Mega, 10 to the 6th. Kilo, 10 to the 3rd. And then notice here deci, centi, and milli, all are actually a lot smaller because they're smaller numbers. So deci is 10 to the negative 1. Centi is 10 to the negative 2. Milli is 10 to the negative 3. Micro is 10 to the negative 6. Now notice there's a jump here. Deci, centi, milli is negative 1, negative 2, negative 3. As soon as you get to micro, it's actually 10 to the negative 6th. Nano is 10 to the negative 9th. And pico is 10 to the negative 12th. Now if you notice right here, it actually kind of corresponds. They balance each other out. And that's how I remember it. I know a lot of people use mnemonics. And I've heard the great mighty king drinks chocolate milk. And then I've never heard one for these. When I was in middle school, I learned the great mighty king drinks chocolate milk and was just told I had to memorize these ones the older I got within college and throughout undergrad. So, whatever you'd prefer to do in that situation. So I think the best example I could do, which is quite simple, would actually be 12 meters to centimeters. So you'd write 12 meters, and then you do a conversion, or I call it a bridge. So you always want to put what you have or you're known on the bottom, and then what you want to become or get to on the top. And it would be 1 centimeter is equivalent to how many meters? So you go over here, you say centimeter. So right here, 10 to the negative 2. So you'd want to insert 10 to the negative 2, and you'd actually do your calculation. I use a calculator. It is simple math. You could definitely do the decimal system where you move your decimal over places. But for all purposes of this, I'm just going to do it on my calculator. And the answer is 1,200 centimeters. And that is your answer. You can also do it the other way around, where you say you have 162 milliliters, and you want to go bigger. How many liters are there? So do 162 milliliters. And we have milliliters, we put them on the bottom, and we want liters, so put it on the top. 1 milliliter is equivalent to, let's go to milli, 10 to the negative 3 liters. Plug into your calculator, do your calculation by hand, however you prefer. 0.162 liters. It's actually quite simple. You should definitely memorize these just for chemistry purposes and other science purposes, but there's also plenty of graphs out there to help you remember the numbers. And then on top of the metric system, we're going to talk about temperature conversions, which is the one I use the most in Australia, and also every time I've been to Europe, because they do all their temperatures in Celsius, as I mentioned. And it's extremely confusing to me when someone says it is 21 degrees outside, and I'm thinking it is freezing, but really it is not, because they're doing Celsius and I'm used to Fahrenheit. It's actually quite simple. These numbers are exact. Let me note of that for you. Numbers are exact. So definitely remember that. So it's a very simple math equation. If you've ever done high school algebra, then you're more than capable of doing this. You just plug and chug. Easy as that. If you want to Fahrenheit to Celsius, you plug in the numbers, and we'll do the example of degrees Fahrenheit. Now, I couldn't get the degrees to go on here. My keyboard didn't allow it. So say your Fahrenheit is 98 degrees. Something that we've all are used to here in the hot summer in California. But what we want to do is plug it in. So if 98 degrees is what Fahrenheit is, plug it in, equals 1.8 degrees Celsius, or Celsius degrees, plus 32, minus 32, minus 32. We get 66, equals 1.8 degrees Celsius. It's all simple math, something we've all probably done in high school, if not in college as well. 3. Now, sig figs do occur, but for all purposes of this video, I'm just going to go ahead and round up to make it a little bit more easy for us to understand. So I said roughly 37. Do the little squiggle sign. And that is how we get it. It's very, very simple to do. It's just a lot of practice of plugging and chugging in and understanding which numbers go where and how to label it. For another example, we can also go Kelvin. Kelvin is a very common measurement of temperature we use in chemistry and other science classes, predominantly chemistry, and we'll use it a lot in the class we're currently in. And so a good one would be, let's just say we are given 38 degrees Celsius. We'll just kind of move the one we have here and move it over here, just for all purposes of this little video. Also to keep it very simple. So you want to know Kelvin. K equals Kelvin, 37 degrees Celsius, because it's what we have. That's 273.15. In this case, it's just simple addition. Equals 310.15. Now, sig figs are important, as Professor has told us, but for all intents and purposes, what I do when I'm doing generalized temperature changes is just round it to the nearest. Just think about it like this. If you're in Australia and you're walking up and down the coast, beautiful Bondi Beach, you're not thinking about sig figs, you're thinking about how hot is it out and how much sunscreen do I need? Temperature is actually one of the easiest conversions, I think. What you really need to do, similar to the metric system, is you need to memorize these little formulas. Because if you can memorize them, you'll be good to go. And you can also do temperature calculations on the fly, so if you do travel anywhere, you can actually tell how hot it truly is outside, or how cold it could potentially be. Yeah. Thank you for watching.